So let's start with trying to get some insight into the small signal method. Okay, I am looking for your help in trying to figure out a technique in order to get a linear response from something that is highly nonlinear. Okay, what I'd like you to do is focus at this point. Okay, I would like you to focus at this little point, this little segment of this curve. Okay, so this is the IV curve, and now this is a 0 point. I'd like you to focus on this little point, and think of that point centered around some value VD, and there is some corresponding value of ID at that point. So I have this small little segment here, and I want you to focus on that. Okay, so I want you to look at that point carefully. Okay, focus on that point exactly. What does it look like? Okay, does it say something to you? Okay, what does that segment really look like? And I promised you the Zen thing here. So start focusing really deeply on that point. Okay, you focus really deeply on that point at that little segment. What does that look like? Okay, so this is my nonlinear curve, but what does this little segment here remind you of? What does it look like? Well, if you look at it carefully enough and do the Zen thing, as I promised, this small region, amazingly enough, looks more or less linear. Okay, so if you look at this small little line here, okay, that small little line there looks more or less linear, and that little segment is about the point VDID. Okay, so that is a key piece of insight that I'm going to exploit and go berserk with it and try to really develop linear responses out of nonlinear circuits with that little piece of insight. And what is that insight? The insight is that if I take this nonlinear curve and look at that small segment of a line and focus on it, it looks more or less linear about the point ID and VD. Okay, so how do I relate that to electrical engineering, and how do I get some response out of that? Well, in order to do so, let's look at this picture. So in this picture, I've drawn you a little segment of line and a little approximate line there, and that looks more or less linear. And what I'm going to do now is, if you look at my input, this is my input here, and clearly that piece of input, right, as placed, is articulating this large region of the curve, particularly in a region where I'm not getting any particularly useful response. So as a first step, what I'm going to do is the following. I would really like this input variation that I have here to somehow articulate this region of the curve. Okay, I want that input to meander in a way that this region of the curve is exploited. Okay, how do I do that? Well, I can do that by somehow taking this curve and moving the whole curve up. So by somehow taking this input and boosting the input up somehow, okay, I haven't told you how I do it, but if I boost it up somehow, then I might be able to get this close to this regime. And in this particular situation, let's assume that I want to boost it at an offset given by capital VD. If I assume that this point here is at VD higher than the ground value. Okay, how do I do the next step? So far what I've done is I've moved the input and boosted it up such that it is in the vicinity of VD. It seems to meander in the vicinity of VD. But now I'm articulating this region of the curve. But how do I get it to articulate just this small region? Think about it. How do I get this big curve for my input voltage to articulate about just this small region here? Well, let's just make it small. So I take my big input and I make my input a lot smaller so that it is small enough that its peak to peak voltage exactly matches that small segment of line that I cared about. And by doing so, let us say that this value I call VD. Okay, let me just notate it with a small v and a small d just to show that. And this is a very small value. And then I've done two things. One is I have moved this waveform, this small VD, by a distance VD from the origin. And then I have made VD itself extremely small. And by making it small, I am then articulating just that small segment of the VI curve of the exponential device. Okay, so this is still time as before. So what happens now? So now my VD is really small and it's articulating this small region. So what does the output look like? So if I look at my output in this situation, by output I mean the current ID that corresponds to the VD that I've applied. It looks like this. Okay, for changes in the VD here, my output looks like this. My output will now correspond to a change in the value that is also sinusoidal, and the reason is that this is more or less linear. And notice here that this will also be centered around some point, and that point here is at an ID offset above zero. And the value, the meandering has it's a voltage, I'm sorry, it's a current in this case. It's a small current ID that meanders above the offset ID, capital I, capital D. Okay, so this is my time axis, then I'm going to get a small current ID. And again, I use the notation a small I, small d to show that this is going to be a small change in ID corresponding to a small change in VD. So what have I really done here? What I've done is I first of all boosted my input signal by a value VD, and then I have shrunk it, okay, to a small value, small VD. Okay, so I boosted it up and shrunk it to a small value so that it meandered across the small region of the IV curve. And then corresponding to that meandering of the small VD signal, I got a small current ID, small ID that reflected the sinusoidal VD. Okay, and I call that small I, small d, my current ID. And that current was also at an offset ID. And the reason is that I have an offset here of VD, and that gives me a corresponding offset ID here. So notice that by boosting my signal, by adding a DC offset VD to my signal, and then shrinking it, I'm now, in an electrical engineering sense, able to exploit this region of the curve that looks more or less linear. Okay, so as you can see, I'm leaning towards exactly how I use my nonlinear circuit in order to get a linear response. So far I've been dealing with it in a graphical sense. I first showed you that a small piece of the curve looks linear here. And then I said the way I can physically accomplish that is by shrinking my input VD and then boosting it all the way up. And just so there's no confusion, VI and VD are the same thing because notice that this node voltage here, VI equals VD. So whatever I say about VD here applies to the VI that I'm using.